I think this slide also, I really don't have to have it, I guess, so to say. Mostly because this is really just saying what I said down here. But let me just present it anyway. Basically, I'm just saying here that, with the odds in favor of, we'll also see with the odds against. We don't write it as a fraction. We like to write it as a ratio. So you'll see like a number, in this case 1, colon, then a 5. Or not just 5, but any number. Again, that's how we usually write the ratios. Excuse me, odds as a ratio. Probability is a fraction. Although probability, I guess you can write as a decimal or percent, technically, because you can always convert, from one to the other. We saw that. Generally, that's what probability is written as. Okay? And again, this is what I said before. We use the word 2 with ratio. So for this, we'll say 1 to 5. But if we have probability like this, people will say 1 in 5, maybe. Or 1 over 5, I guess. Well, that's what I was saying before, but I guess I should have said 1 in 5. So, okay. All right, good. That's 4. Now, there's also odds against. And what's nice about that is it's actually pretty simple. It's just basically the odds in favor, but you invert it. The odds against. See? So in other words, you just flip the odds in favor of. Then you get the odds against. I mean, you can see from the definition, it's the number of ways an event cannot occur to the number of ways it can occur. The number of ways it cannot occur to the number of ways the event can occur. And again, just like I said before, we can still calculate it using probabilities, right? Essentially, you just take the odds in favor of and you invert it. You flip it. I think that what they also call it is taking the reciprocal. You invert it, that is. So you'll have the probability of not E occurring over the probability of E occurring. E is the event. And again, the complement, I know it came out funny up here. It didn't come out that right, but you can also think of not E occurring, the probability of that, as 1 minus the probability of E. You can also think of it that way. Okay. So essentially, if you know one, you know the other. You just have to know which number comes first, I guess, so to say. Okay? I mean, odds for an event, right? The number of ways the event can occur is the first number. Whereas for against the event, number of ways it cannot occur comes first. Okay. Well, let's do some examples. So let's say, for instance, we're rolling a die. We want the odds for rolling a die and getting a 3. Okay, well, how many ways are there to roll a 3? Well, there's only one way, right? For rolling a die, there's only one way you can roll a 3. Roll a 3. No questions asked, I guess, so to say. But so there's only one way that event can occur. There's only one outcome with rolling a 3. How many ways are there that we do not roll a 3? How many ways we cannot get a 3? Well, there's 5 ways, right? Because there's 5 other outcomes. In other words, the odds for getting a 3 are 1 to 5. 1 to 5. And, oh, no, that's okay, I guess. 1 to 5. That's the odds for getting a 3. And you could also solve it using probability, right? We already saw the probability of rolling a 3, right? That's 1 out of 6. The probability of not rolling a 3, well, there are 5 other outcomes, so we get 5 over 6. And this is what I was saying from the beginning with the fractions you can manipulate. You can multiply top and bottom by 6. And you just end up with 1 over 5. But you know what? Let me write that out. Maybe it'll help. Pen. Let me see if I could do this. 6. Okay, so basically you would multiply top and bottom by 6. then these would cancel. I think I'm making it worse though. But hopefully that's the idea. And what you're left with is 1 over 5. I think I'm making it worse. Let me erase that. So I like writing on a chalkboard because it's easier for me to fix my mistakes or fill in the gaps, so to say. But again, what I'm saying here is we get 1 to 5 as before. Right away, you should notice something interesting. Remember, the probability of getting a 3 is 1 in 6, right? You have a fraction 1 in 6, 1 over 6. Here we have 1 to 5. So notice this is interesting in that probability and the odds in favor of or odds against, it's not quite the same thing. They're related, but that's not quite the same though. That's one example. And then the odds against getting a 3 would be just 5 to 1. You know, you would flip it. So here's another example. What about this? Find the odds of choosing a card at random from the deck of 52 cards. We're going to select a card from the suite of clubs. So again, we're choosing a card at random from a deck of 52 cards, okay? We want to know what are the odds in favor of choosing a card and obtaining a card from the suit of clubs. Well, in the suit of clubs, there are 13 cards, right? So the probability of choosing a card from the suit of clubs is 13 out of 52. And the probability of not choosing such a card, well, it's 1 minus that, which is 48 out of 52. I mean, you could have gotten a 48 correctly because we know there's 48 other cards in the deck. 48 cards that are not in the suit of clubs. So the probability of not choosing a card from the suit of clubs is 48 out of 52. That's another way to handle it. Then to get the odds, you just divide probabilities, right? So in this case, you would have 13 over 52 divided by 48 over 2, and the 52s cancel. Get this. 13 to 48. And we really didn't have to do it this way because we actually know how many outcomes there are in each event. Right? We know the sample space is 52. There's 13 cards in the suit. So the number of outcomes in the event, choosing a card with the suit of clubs, there are 13 cards in that event. There's 48 cards then not in the event. So we could also get it that way. I just like doing it with probability, but that's just me. Okay. Then, what would the odds be against choosing such a card? Well, again, that's easy. You just invert this. It would be 48 to 13. In this case, there are 48 ways that event does not occur, and there are 13 ways that it can occur. So that's another example dealing with odds. There's not much really to it, I guess, at least not much the book does. I mean, that's all there really is. Not for the chapter, we're not done yet, but that's really all there is for odds. Are there any, I'm not done yet, but are there any questions? Yeah, I hope this makes sense. I think it does. There's one more quick thing I want to go through, although we'll start it, but probably won't finish it. That's okay. All right. So remember, I also said we talk about expected value, okay? Well, this is actually expected value. There is a calculation way. There is a way to calculate it, but really it's just how much you can, it's the average gain or loss if the procedure is repeated many times. The idea is if you keep on doing the experiment many, many, many times, it's how much you're going to gain or lose in the long run. Generally with expected value, you use it for events or experiments, that is, where money is at stake. You know, if something happens, you gain money. If something else happens, you lose money. Kind of like in a casino, like a, what do you call it? Like a slot machine or something. I think, in fact, in the book, they actually do this with the game of roulette, I think it's called, where you like spin and see where the marble lands. I mean, that's really the idea. They kind of go through intuitively why expected value is what it is, although I really did not like what they were saying. So that's why I'm trying to do it this way. Basically, that's what expected value is, though. So if you keep on repeating the procedure or experiment, that is, over and over again, expected value is really what it sounds like. It's how much you expect to gain or lose in the long run. And generally, if it's if it's negative, I mean, this is how we can calculate it, but we'll see that shortly. If it's negative, then really you may not want to play it, because in the long run, you're going to lose money. Does it mean you're always going to lose? No. Sometimes you'll win, sometimes you'll lose, but in the end, you'll end up losing money in the long run. Thus, that kind of game you may not want to play. But if it's positive, then sometimes you'll win, sometimes you'll lose, but in the long run, you're going to win money. And again, we say the game is actually fair if the expected value is 0. In the long run, you're not gaining or losing money, and that we say is a fair game. And that's just a definition. So let me see. I didn't write down. Well, I did. Well, here. I did write down what the calculation is. We'll see some examples next time. The whole idea is you multiply each outcome by the probability and then add up the products. You'll see what I mean next time. I know it's a little confusing now. I really don't want to do an example now, because I feel like I'll have to rush through it. But again, when I say outcome, I mean there's going to be some money that occurs. So an outcome would be you gain $1. And then you say, okay, well, what's the probability that will happen? Or another outcome could be you lose $10. And then you find the probability that that happens. And then you would multiply each outcome with its probability. You add up those products. That's what the expected value is. So I guess we'll stop here.